Pointers, learning objectives. In this chapter, the user would learn the following in detail: address operators, pointer type declaration, pointer assignment, pointer initialization, pointer arithmetic, functions and pointers, arrays and pointers, pointer arrays. What are pointers? A pointer is a special variable which holds the address of the variable it has pointed to. Basic concept of a pointer. Consider above diagram. I is the name given for a particular memory location. Consider its corresponding address be 65524 and the value stored in variable I is 5. The address of the variable I is stored in another integer variable whose name is j and which is having corresponding address 65522. Thus, one can say that j is equal to and I semicolon, that is, j is equal to address of I. Here, j is not an ordinary variable. It is a special variable and called pointer variable as it stores the address of the ordinary variable. Address operator in C programming. It is denoted by AND. When used as a prefix to a variable name, AND operator gives the address of that variable. Example, AND N gives address on N. How address operator works? Hash include lesser than stdio.h greater than void main open close bracket int n is equal to 10 print f open bracket open quote \n value of n is %d close quote comma n close bracket semicolon print f open bracket open quote \n value of and n is %u close quote semicolon and n close bracket close quotes. Output value of n is 10, value of and n is 1002. Visual understanding. Consider the following program. Pointer variable, address of that variable. After declaration, memory map will be like this: inti is equal to 5, int asterisk ptr semicolon. Values. After assigning the address of variable to pointer, that is, after the execution of this statement, ptr is equal to and I semicolon. Invalid use of address operator. Programmer cannot use address operator for accessing address of literals. Only variables have addresses associated with them and 75. A plus B will evaluate addition of values present in variables. Output of A plus B is nothing but literal, so one cannot use address operator and open bracket A plus B close bracket. Again, A is a character literal, so he cannot use address operator and open bracket open quote A close quote close bracket. Declaring pointers. A pointer is a numeric variable and, like all variables, must be declared before it can be used. Pointer variable names follow the same rules as other variables and must be unique. This chapter uses the convention that a pointer to the variable name is called p_name. This isn't necessary, however. One can name pointers to anything within C's naming rules. A pointer declaration takes the following form: type name asterisk ptr name semicolon. Type name is any of C's variable types and indicates the type of the variable that the pointer points to. The asterisk is the indirection operator and it indicates that ptr name is a pointer to type name and not a variable of type name. Pointers can be declared along with non-pointer variables. char asterisk ch1 asterisk ch2 semicolon ch1 and ch2 both are pointers to type char. Syntax for pointer declaration in C. Data type asterisk open bracket pointer underscore name close bracket semicolon. Explanation. Data type of variable that the pointer points to, or data type whose address is stored in pointer underscore name. Asterisk. Asterisk is called as indirection operator. It is also called as value at address operator. It indicates variable declared is of pointer type. Pointer underscore name. Must be any valid C identifier. Must follow all rules of variable name declaration. Ways of declaring pointer variable. Can appear anywhere between pointer underscore name and data type. Int asterisk p semicolon. Int asterisk space p semicolon. Int space asterisk space p semicolon. Pointer assignments. To assign an address to a pointer, we'll need a new operator, the address of operator. Once assigned, the pointer will contain the address of the assigned variable, not its value. Code example. int asterisk xp semicolon / declares xp as a pointer to an integer. xp is equal to and x semicolon / xp receives the address of x. Pointer variables can be assigned int asterisk p1 comma asterisk p2 semicolon. p2 is equal to p1 semicolon assigns one pointer to another. Makes p2 point to where p1 points. Do not confuse with asterisk p1 is equal to asterisk p2. Assigns value pointed to by p1 to value pointed to by p2. Example program for pointer assignments. Output. Initialization. How to initialize pointer in C programming, pointer and variable. Above is the syntax for initializing pointer variable in C. Initialization of pointer can be done using following steps. Declare a pointer variable and note down the data type. Declare another variable with same data type as that of pointer variable. Initialize ordinary variable and assign some value to it. Now initialize pointer by assigning the address of ordinary variable to pointer variable. The following example will clearly explain the initialization of pointer variable. Hash include open bracket stdio.h close bracket. int main open close bracket. int a semicolon. int into ptr colon / pointer declaration. a hyphen 10 semicolon / assign some value. ptr hyphen and a semicolon / pointer initialization. Explanation of above program. Pointers should not be used before initialization. Open quote ptr close quote is pointer variable used to store the address of the variable. Stores address of the variable a. Now ptr will contain the address of the variable a. Note, pointers are always initialized before using it in the program. Example program for initializing integer pointer. Output value of ptr colon 4001. Pointer initialization. Initializing pointers. Like regular variables, uninitialized pointers can be used, but the results are unpredictable and potentially disastrous. Until a pointer holds the address of a variable, it isn't useful. the address doesn't get stored in the pointer. The program must put it there by using the address of operator, the ampersand and. When placed before the name of a variable, the address of operator returns the address of the variable. Therefore, one has to initialize a pointer with a statement of the form pointer is equal to and variable. The program statement to initialize the variable p_rate to point at the variable rate would be p_rate equal to and rate semicolon. Assign the address of rate to p_rate. Before the initialization, p_rate didn't point to anything in particular. After the initialization, p_rate is a pointer to rate. Example for initializing pointers program. Output pointers and variable types. The previous discussion ignores the fact that different variable types occupy different amounts of memory. For the more common PC operating systems, an INT takes 2 bytes, a float takes 4 bytes, and so on. Each individual byte of memory has its own address, so a multi-byte variable actually occupies several addresses. How then do pointers handle the addresses of multi-byte variables? Here's how it works. The address of a variable is actually the address of the first, lowest byte it occupies. This can be illustrated with an example that declares and initializes 3 variables. These variables are stored in memory. In this, the int variable occupies 2 bytes, the char variable occupies 1 byte, and the float variable occupies 4 bytes. Different types of numeric variables occupy different amounts of storage space in memory. Pointer arithmetic. See table and observe. Have declared some of the variables and also assumed address for the declared variables. One can see address of a variable after performing arithmetic operations. It clearly shows that one can add or subtract address and integer number to get valid address. A programmer can even subtract 2 addresses, but he cannot add 2 addresses. Arithmetic pointers incrementing. When one increments a pointer, he is increasing its value. For example, when one increments a pointer by 1, pointer arithmetic automatically increases the pointer's value so that it points to the next array element. In other words, C knows the data type that the pointer points to from the pointer declaration and increases the address stored in the pointer by the size of the data type. Suppose that ptr_2_int is a pointer variable to some element of an int array. If execute the statement ptr_2_int ++ semicolon, the value of ptr_2_int is increased by the size of type int, usually 2 types, and ptr_2_int now points to the next array element. Likewise, if ptr_2_float points to an element of a type float array, the statement ptr_2_float ++ semicolon. It increases the value of ptr_2_float by the size of type float, usually 4 bytes. The same holds true for increments greater than 1. If the value n is added to a pointer, C increments the pointer by n array elements of the associated data type. Therefore, ptr_2_int plus is equal to 4, semicolon. increases the value stored in ptr underscore 2 underscore int by 8, assuming that an integer is 2 bytes, so it points 4 array elements ahead. Likewise, colon ptr underscore 2 underscore float plus is equal to 10, semicolon. Increases the value stored in ptr underscore 2 underscore float by 40, assuming that a float is 4 bytes, so it points 10 array elements ahead. Example for pointer arithmetic program. Output: arithmetic pointers decrementing. The same concepts that apply to incrementing pointers hold true for decrementing pointers. Decrementing a pointer is actually a special case of incrementing by adding a negative value. If one decrements a pointer with the minus or equal to operators, pointer arithmetic automatically adjusts for the size of the array elements. Suppose that ptr underscore 2 underscore int is a pointer variable to some element of an int array. If this statement is executed, colon ptr underscore 2 underscore int minus semicolon, the value of ptr underscore 2 underscore int is decreased by the size of type int, usually 2 bytes, and ptr underscore 2 underscore int now points to the next array element. Likewise, if ptr underscore 2 underscore float points to an element of a type float array, the statement ptr underscore 2 underscore float minus semicolon decreases the value of ptr underscore 2 underscore float by the size of type float, usually 4 bytes. Example for arithmetic pointers decrementing program. Output: other pointer manipulations. The only other pointer arithmetic operation is called differencing, which refers to subtracting two pointers. If one has two pointers to different elements of the same array, we can subtract them and find out how far apart they are. Again, pointer arithmetic automatically scales the answer so that it refers to array elements. Thus, if ptr1 and ptr2 point to elements of an array of any type, the following expression tells how far apart the elements are: ptr1 minus ptr2. Pointer comparisons are valid only between pointers that point to the same array. Under these circumstances, the relational operators work properly. Lower array elements, that is, those having a lower subscript, always have a lower address than higher array elements. Thus, if ptr1 and ptr2 point to elements of the same array, the comparison is ptr1 lesser than ptr2 is true if ptr1 points to an earlier member of the array than ptr2 does. Pointers and function. When the program is executed, the code for each function is loaded into memory starting at a specific address. A pointer to a function holds the starting address of a function, its entry point. The code for each function is loaded into memory starting at a specific address. Like other pointers, one must declare a pointer to a function. The general form of the declaration is as follows. Type, open bracket, asterisk ptr underscore 2 underscore func close bracket open bracket parameter underscore list close bracket semicolon. What is function pointer? Function pointer. A pointer which keeps address of a function is known as function pointer. Three steps to use pointer to call function. Declare pointer which is capable of storing address of function. Initialize pointer variable. Call function using pointer variable. Step 1. Declaring pointer. Void asterisk open bracket asterisk ptr close bracket open close bracket colon. Declare double pointer. Write open close bracket symbol after double pointer. Void represents that function is not returning any value. Open close bracket represents that function is not taking any parameter. Step 2. Initializing pointer. ptr is equal to and display. This statement will store address of function in pointer variable. Step 3. Calling a function. Open bracket asterisk ptr close bracket open close bracket semicolon. Using open bracket asterisk ptr close bracket open close bracket, one can call function display open close bracket semicolon. Open bracket asterisk ptr close bracket open close bracket is equal to open bracket asterisk ptr close bracket open close bracket semicolon. Open bracket asterisk and display close bracket open close bracket semicolon. Open bracket display close bracket open close bracket semicolon. Display open close bracket. Thus, open bracket asterisk ptr close bracket open close bracket is as good as calling function. Example program for function having two pointer parameters and return type as pointer. Output. This statement declares ptr underscore 2 underscore func as a pointer to a function that returns type and passes the parameters in parameter list. Here are some more concrete examples. Functions declaration. Pointer declaration. Assigning the address of functions to pointer. The first line declares func1 as a pointer to a function that takes one type integer argument and returns as a type int. The second line declares func2 as a pointer to a function that takes two type double arguments and has a void return type or no return value. The third line declares func3 as a pointer to a function that takes an array of pointers to type char as its argument and returns to type char. The final line declares func4 as a pointer to a function that doesn't take any arguments and has a void return type. Initializing and using a pointer to a function. A pointer to a function must not only be declared but also initialized to pointer something. The something is, of course, a function. There is nothing special about a function that gets pointed to. The only requirement is that its return type and parameter list match the return type and parameter list of the pointer declaration. For example, the following code declares and defines a function and a pointer to that function. Because the function square open close bracket and the pointer p have the same parameter and return types, one can initialize p to point to square as follows: ptr is equal to square semicolon. Then a programmer can call the function using the pointer as follows: answer is equal to ptr open bracket x close bracket semicolon. the array name as pointers. An array name without brackets is a pointer to the array's first element. Thus, if a programmer has declared an array data, open close bracket, data is the address of the first array element. For example, the following code initializes the pointer variable p_array with the address of the first element of array, open close bracket. Arrays and pointers. p_array is a pointer variable. It can be modified to point elsewhere. Unlike array, p_array isn't locked into pointing at the first element of array, open close bracket. Example, it could be pointed at other elements of array, open close bracket. Pointer pointing to the array of elements. Array and pointer are backbones of the C programming language. Pointer and array both are closely related. Array name without subscript points to first element in an array. Example, one-dimensional array. int a open bracket 10 close bracket semicolon. Here a, open bracket 0 close bracket both are identical. Example, two-dimensional array. int a open bracket 10 close bracket open bracket 10 close bracket semicolon. Here a, open bracket 0 close bracket open bracket 0 close bracket both are identical. Let x is an array, I is subscript variable. X open bracket I close bracket is equal to asterisk open bracket x plus I close bracket is equal to asterisk open bracket I plus x close bracket is equal to I open bracket x close bracket. Proof of the above formula. For the first element of array I is equal to 0, x open close bracket 0 is equal to asterisk open bracket x plus 0 close bracket is equal to asterisk x. The first element of array is equivalent to asterisk x. Thus, asterisk x plus I will give us value of ith element. An array without brackets is a pointer to the array's first element. Therefore, one can access the first array element using the indirection operator. If array open close bracket is a declared array, the expression asterisk array is the array's first element, asterisk open bracket array plus 1 close bracket is the array's second element, and so on. This illustrates the equivalence of array subscript notation and array pointer notation. If one can generalize for the entire array, the following relationships hold true. Example program for arrays and pointers. Output. Example program for array subscript notation and pointers. Output. Strings and pointers. To allocate and initialize a string is to declare an array of type char as follows. Char message open close bracket is equal to this is the message semicolon. One could accomplish the same thing by declaring a pointer to type char semicolon. Char asterisk message is equal to this is the message semicolon. Example for strings and pointers program. Output. arrays of pointers to type char. The following statement declares an array of 10 pointers to type char. Char asterisk message open bracket 10 close bracket 10 semicolon. Each element of the array message open close bracket is an individual pointer to type char. One can contribute the declaration with initialization and allocation of storage space for the strings. Char asterisk message open bracket 10 close bracket is equal to open bracket 1, 2, 3 close bracket semicolon. This declaration does the following. It allocates a 10-element array named message. Each element of message is a pointer to type char. It allocates space somewhere in memory and stores the 3 initialization strings, each with a terminating null character. It initializes message open bracket 0 close bracket to point to the first character of the string open quote 1 close quote, message open bracket 1 close bracket to point to the first character of the string open quote 2 close quote, and message open bracket 2 close bracket to point to the first character of the string open quote 3 close quote. Array of pointers. Step 1. Array of function. Int open bracket asterisk arr open bracket 3 close bracket open close bracket semicolon. Above statement tells that arr is an array of size 3. Array stores address of functions. Array stores address of function having integer as return type and does not take any parameter. Step 2. Declaring array of function pointer. Int open bracket asterisk ptr close bracket open bracket 3 close bracket 3 open close bracket semicolon. It is an array of function pointer which points to array of function. Step 3. Store function names inside function array. Arr open bracket 0 close bracket is equal to display semicolon. Arr open bracket 1 close bracket is equal to getch semicolon. Step 4. Store address of function array to function pointer. Ptr is equal to and arr semicolon. Step 5. Calling function. Following syntax is used to call display function colon open bracket asterisk ptr close bracket open close bracket semicolon. This syntax is used to getch function colon y open bracket asterisk ptr plus 1 close bracket open close bracket semicolon. Pointers to structures. A structure is a collection of variables within one variable. Structures can be termed as a variable that aggregates variable of different or similar types. This collection of structures and pointers is very strong. A structure provides a very intuitive way to model user-defined entities, open bracket, records, packet formats, image headers, etc. Defining structures. The keyword in C that is used to define a structure is ptr_struct. Structures can contain variables of any kind that are permissible by the C language. They can also contain another structure pointer variable within themselves. The following is an example of a typical way in which pointers to structures are defined. Dynamic memory allocation. In general, there are two types of storage available for variables. They are stack and heap memory storages. Values. Memory address for values. The stack memory is permanent storage area where the ordinary variables can be stored. The heap memory is the free memory area available in the main memory of the computer, which will be used for dynamic memory allocation. In C, there exists a set of built-in functions which is used to allocate memory dynamically to the derived data type like arrays, structures, and unions. Some of the important functions are 1. Malloc, open close bracket. 2. Calloc, C-A-L-L-O-C, open close bracket. And 3. Free, open close bracket. M-A-L-L-O-C, open close bracket. The general syntax of the malloc open close bracket function is pointer variable is equal to open bracket data type asterisk close bracket malloc open bracket number of types to be allocated close bracket semicolon. Example: int asterisk x comma n semicolon. X is equal to open bracket int asterisk close bracket malloc open bracket n asterisk size of open bracket int close bracket semicolon. Here x is the pointer variable of int data type and n is an int type variable which can hold the value of the size of the array to be read in. The malloc malloc open close bracket function allocates a single contiguous memory of n locations of int type for the pointer variable x such that x can become like an array of n int values and the memory location address of the first element of the array is stored in x. This will provide the understanding of the connection between the pointers and arrays. The malloc malloc open close bracket function does not initialize the allocated memory by default, so one has to perform initialization separately before using them. For the above example, it can be done simply as we do initialization for any array and is given below. For open bracket I is equal to 0 semicolon I lesser than n semicolon I plus plus close bracket. X open bracket I close bracket is equal to 0 semicolon. In general, malloc function is used to allocate memory for basic data types like int, char, float, and double. In order to allocate memory dynamically for derived data types like structures and unions, calloc open close bracket function is used. Calloc, calloc open close bracket. The general syntax of the calloc function is pointer variable is equal to open bracket data type asterisk close bracket calloc open bracket number of bytes to be allocated close bracket semicolon. Example: int asterisk x comma n semicolon. X is equal to open bracket int asterisk close bracket calloc open bracket n comma size of open bracket int close bracket semicolon. The above example is similar to the malloc open close bracket function but with the following changes. Here there are two arguments that are used to specify the number of bytes to be allocated. The calloc function allocates a number of blocks of memory in contiguous form and not as a single contiguous block of memory allocated by malloc open close bracket function. Since the calloc open close bracket function allocates memory as number of blocks even in the case of a single contiguous block of memory is not available. The other important aspect is that the calloc open close bracket function initializes the allocated memory by default. So, one need not initialize the allocated memory as in the case of malloc open close bracket function. This calloc open close bracket function is used to allocate memory for derived data types like arrays, structures, and unions. differences between malloc open close bracket and calloc open close bracket functions. The main difference between the two dynamic memory allocation functions, malloc open close bracket and calloc open close bracket, available in C, are given in a table. Malloc open close bracket, it allocates single contiguous block of memory only. Calloc, it allocates number of blocks of memory in contiguous form. Malloc, memory allocation is not initialized by default. Calloc, memory allocation is initialized by default. Malloc, it is used to allocate memory for basic data types like int, char, float and double. Malloc, it is used to allocate memory for derived data types like arrays, structures and unions. Free open close bracket, dynamically allocated memory with either calloc or malloc does not get returned on its own. The programmer must use free open close bracket especially to release space. Syntax of free open close bracket. Free open bracket ptr close bracket semicolon. This statement causes the space in memory pointer by ptr to be deallocated. Free list. Slide 51. Examples of calloc and malloc. Write a C program to find sum of n elements entered by user. To perform this program, allocate memory dynamically using malloc function. Output. Write a C program to find sum of n elements entered by user. To perform this program, allocate memory dynamically using calloc function. Output. Conclusion. In this chapter, we have covered the following aspects of pointers: address operators, pointer type declaration, pointer assignment, pointer initialization, pointer arithmetic, functions and pointers, arrays and pointers, pointer arrays.